US Physics Olympiad, year 2013, F equal MA, first round. For the first round, that was given 25 problems, and for that it was given 75 minutes. All solutions for all these problems you can find below this video in the reference of the description. Problem number 1. An observer stands on the side of the front of a stationary train. When the train starts moving with a constant acceleration, it takes 5 seconds for the first car to pass the observer. How long will it take for the 10th car to pass? Problem number 2. Georgie stands 20 meters from a wall and Diego stands 10 meters from the same wall. Georgie throws a ball at an angle of theta equal 30 degrees above the horizontal, and it collides elastically with the wall. How fast does Georgie need to throw the ball so that Diego will catch it? Consider Georgie and Diego to be the same height, and both are on the same perpendicular line from the wall. Problem number 3. Tom throws a football to Wes, who is a distance L away. Tom can control the time of flight t of the ball by choosing any speed up to v maximum and any launch angle between 0 and 90 degrees. Ignore air resistance and assume Tom and Wes are at the same height. Which of the following statements is correct? A. If v maximum less than square root from dl, the ball cannot reach Wes at all. B. Assuming the ball can reach Wes at v maximum increases with the L held fixed, the minimum value of t decreases. C. Assuming the ball can reach Wes as v maximum increases with the L held fixed, the maximum value of t increases. D. Assuming the ball can reach Wes as L increases with the v maximum held fixed, the maximum value of t increases. E. Assuming the ball can reach Wes as L increases with the v maximum held fixed, the maximum value of t increases. US Physics Olympiad, year 2013, F equal MA, first round. Problem number 4. The sign shown below consists of 2 uniform legs attached by a frictionless hinge. The coefficient of friction between the ground and the legs is μ. Which of the following gives the maximum value of theta such that the sign will not collapse? Problems 5 and 6. The following information applies to questions 5 and 6. A student steps onto a stationary elevator and stands on a bathroom scale. The elevator then travels from the top of the building to the bottom. The student records the reading on the scale as a function of time. Question: at what times does the student have maximum downward velocity? Question 6. How tall is the building? Problem number 7. A light car and a heavy truck have the same momentum. The truck weighs 10 times as much as the car. How do their kinetic energies compare? Problems 8 and 9. The following information applies to questions 8 and 9. The truck is initially moving at a velocity v. The driver presses the brake in order to slow the truck to a stop. The brake applies a constant force F to the track. The track rolls a distance x before coming to a stop, and the time it takes to stop is t. Question 8. Which of the following expression is equal the initial kinetic energy of the track? It means the kinetic energy before the driver starts braking. Question B. Question 9. Which of the following expressions is equal the initial momentum of the track? Problem number 10. Which of the following can be used to distinguish a solid ball from a hollow sphere of the same radius and mass? Problem number 11. A right triangle wooden block of mass big M is at rest on a table, as shown in the figure. Two small wooden blocks, both with mass small m, initially rest on the two sides of the larger block. As all contact surfaces are frictionless, the smallest cube starts sliding down the larger block while the block remains at rest. What is the normal force from the system to the table? Problem number 12. A spherical shell of mass big M and radius r is completely filled with a frictionless fluid, also of mass big M. It is released from rest, and then it rolls without slipping down an incline that makes an angle theta with the horizontal. What will be the acceleration of the shell down the incline just after it released? Assume the acceleration of a free fall is g. The moment of inertia of a thin shell of radius r and mass m about the center of mass is I equal 2/3 mr squared. The moment of inertia of a solid sphere of radius r and mass m about the center of mass is I equal 2/5 mr squared. Problem number 13. There is a ring outside of Saturn. In order to distinguish if the ring is actually a part of Saturn or is instead a part of the satellites of Saturn, we need to know the relation between the velocity v of each layer in the ring and the distance r of the layer to the center of Saturn. Which of the following statements is correct? Problem number 14. A cart of mass m moving at 12 meters per second to the right collides elastically with a cart of mass 4 kg that is originally at rest. After the collision, the cart of mass m moves to the left with a velocity 6 meters per second. Assuming an elastic collision in one dimension only, what is the velocity of the center of mass of the two carts before the collision? Problem number 15. A uniform rod is partially in water with one end suspended, as shown in the figure. The density of the rod is 5/9 that of water. At equilibrium, what portion of the rod is above water? Problem number 16. A very large number of small particles forms a spherical cloud. Initially, they are at rest, have a uniform mass density per unit volume ρ0, and occupy a region of radius r0. The cloud collapses due to gravitation. The particles do not interact with each other in any other way. How much time passes until the cloud collapses fully? The constant 0.5427 is actually a square root from 3 pi over 32. Problem number 17. Two small equal masses are attached by a lightweight rod. This object orbits a planet. The length of the rod is smaller than the radius of the orbit, but not neglectable. The rod rotates about its axis in such a way that it remains vertical with respect to the planet. Is there a force in the rod? If so, is it tension or compression? Is the equilibrium stable, unstable, or neutral with respect to a small perturbation in the angle of the rod? Assume this perturbation maintains the rate of rotation, so that in the co-rotating frame the rod is still stationary but at an angle to the vertical. Problem number 18. 2-point particles, each of mass 1 kg, begin in the state shown in the upper left corner. The system evolves through internal forces only. Which of the following could be the state after some time has passed? Problems 19 to 21. The following information applies to questions 19, 20, and 21. A simple pendulum experiment is constructed from a point mass m attached to a pivot by a massless rod of length L in the constant gravitational field. The rod is released from an angle θ0 less than pi/2 at rest, and the period of motion is found to be t0. Ignore air resistance and friction. Question 19. At what angle θg during the swing is the tension in the rod the greatest? Question 20. What is the maximum value of the tension in the rod? Question 21. The experiment is repeated with a new pendulum with a rod of length 4L using the same angle θ0, and the period of motion is found to be t. Which of the following statements is correct? Problem number 22. A simplified model on the foot is shown. When a student of mass m equal 60 kg stands on a single toe, the tension T in the Achilles tendon is closest to. Problems number 23 and 24. The following information applies to questions 23 and 24. A man with a mass m jumps off of a high bridge with a bungee cord attached to his ankles. The man falls through a maximum distance big H, at which point the bungee cord brings him to a momentary rest before he bounces back up. The bungee cord is perfectly elastic, obeying Hooke's force law with a spring constant K, and stretches from an original length of L0 to a final length L equal L0 plus small h. The maximum tension in the bungee cord is 4 times the weight of the man. Questions. Question 23. Determine the spring constant K. Question 24. Find the maximum extension of the bungee cord, small h. Problem number 25. A box with a weight W will slide down a 30 degrees incline at constant speed under the influence of gravity and friction alone. If instead a horizontal force P is applied to the box can be made to move up the ramp at constant speed. What is the magnitude of P?